Hi guys, welcome to our channel. In this video, we want to talk about what is an algorithm. Ever wondered how Google Maps knows the fastest route, or how YouTube mysteriously predicts videos that feel like they have peeked into your thoughts? Want to know more? Let's jump right in. Let us start with a simple definition of an algorithm. An algorithm is a finite set of crystal clear instructions which are performed in a step-by-step sequence in order to solve a problem. You are using algorithms in your everyday life, asking it to make recommendations for you without even noticing it. From your fridge to Google Maps, algorithms are everywhere, silently working behind the scenes. Let's continue with a simple and perfect example of an algorithm in action. Consider the instructions needed to make a cup of delicious iced coffee. Starting with the first step of the algorithm, you will have to gather all necessary ingredients, including a cup, a sachet of instant coffee, milk, hot water, and some ice cubes. Moving on to the second step, you'll have to add the sachet of coffee to the cup. Then add a quarter cup of hot water to the cup, mix the ingredients, add ice, add half a cup of milk, and in the last step, you should mix all the ingredients once more. Here you are with a delicious cup of iced coffee by following only 7 steps of an algorithm. Easy, huh? Let's continue with a little bit more complex example. Consider you want to search for the meaning of a word like computer in the dictionary. What possible steps would you follow in this new problem? Here is a simple algorithm for it. Let's go through it step by step. Obviously, you'll have to open the dictionary in the first place. The second step is a simple example of a loop in an algorithm that executes a series of instructions for a finite or even infinite number of steps. In this example, it checks words in the dictionary in order and one by one until it reaches the last word in the dictionary, unless there is an instruction in the body of the loop that suggests we can break it sooner. We'll see that soon. The third line of the algorithm is indented compared with the second line, which is shown by dashed lines. It means that this instruction is a part of the for instruction and will be repeated for each word in the dictionary. It also starts with the keyword if, which represents a conditional statement, meaning that the next instruction will be executed if and only if the word is equal to computer. The first word in the dictionary is a, and it is not equal to computer. Therefore, the fourth line will not be executed since the condition was not fulfilled. As we have not gone through each word in the dictionary yet, the loop is repeated and the algorithm goes on to the next word in the dictionary, which is aback. Aback is again not equal to computer, and therefore the fourth line will not be executed, so the algorithm goes back to the second line. This iteration will go on for each word in the dictionary until at some point,
one eternity later,
we encounter the word computer, and only then the fourth line will be executed, since the condition of the if instruction is true. And finally, the meaning of computer is fetched from the dictionary. These two algorithms were two really simple algorithms to solve simple problems. But are these the best algorithms that can be written for these problems? We can always try to improve our algorithms and make them work more efficiently. Simply, we could ask ourselves 2 important questions. Is this algorithm producing the results we expected? And is this the most optimal way to get these results? Remember our coffee algorithm which gave us a delicious cup of iced coffee? Is this algorithm producing the results we expected? It seems that it is giving the correct results, but wait, what? Your friends coming over? Then this algorithm won't produce the results we expect since you cannot give only 1 cup of coffee to more than 1 person. We have to write a new algorithm that suits the new situation too. Assume that the variable n declares the number of friends you are having over. N can be 3 friends, 5 friends, 8 friends, 11 friends, or any other number of people. You should have an algorithm that works correctly no matter how many friends you're having over. For start, you may want to multiply the number of ingredients by the number of guests, which is n. Only this way you will be assured that you have enough ingredients for the guests, and then simply repeat the following steps n times. Then the new algorithm would be something like this, that repeats the 3rd to the 9th step n number of times. Now you have n cups of iced coffee ready to be served to n friends. Now let's tackle the search dictionary algorithm and how we can improve it. Assume that this time we want to search for the word zucchini. Then the presented algorithm won't work anymore since it is designed to only find the word computer. Therefore, we have to declare a new variable that stores the word we are going to look for, which is our target word, and change it each time the meaning of a new word is wanted. Then we can search for computer, zucchini, or any other arbitrary word. This new algorithm works perfectly and produces the results we expected, but is this the most optimal way to get these results? If the target word is zucchini, we have to start from the first page and go word by word all the way from A, B, C, D to Z to be able to find zucchini at the end of the dictionary. Pretty time-consuming, huh? Wouldn't it be more optimal if you could just jump straight to category Z and search there for zucchini? A lot of time would be saved that way. But how to decide what category should we move to for each word? We just have to extract the first letter of the word, and there it is, the category in which we have to look for the word. Then our algorithm would look something like this. That is all it takes to know about the meaning of an algorithm. Thank you for watching. If you want to dive deep into the world of computer science or algorithms, continue watching our videos.